Okay, in this video we're going to talk about how your system works. This is about a DI system, which is called deionizing. Now, again, I'm going to use a whiteboard, and it's a lot of theory, but it's worth understanding, because then you know exactly why you've got pure water and why your windows are clean. Okay? So there's 3 stages in a DI system. The first stage is called sediment. Yeah? And the sediment filter, its job, so we'll draw it like this, and its job, it's very finely woven, between 1 and 5 micron. And its job is to catch large particles, algae. So if the town supply water is being flushed, then quite often you'll see a lot of green come through. When we change this filter, it'll be green. Other times there might be, you go into an old area of a town and there's old pipes and the water's rusty, or again they've turned the water off and then they turn it on again, and then all of a sudden when we take this filter out it's like rusty brown. So this filter is designed to protect the rest of the filters from these large particles that could destroy the efficiency of, in particular, of the DI resins, which are consumable. The second filter that we've got is called a carbon filter. And if you compare it, the carbon filter's kind of got a netting around the outside, so I'll just draw it like that. And you'll know the difference when you see them later. The carbon filter's job is actually to take out chlorine. Now the reason we want to take out chlorine is that the chlorine will destroy the DI resins. They attack the integrity of the resins, and also the chlorine is a 2- charge, so the chlorine as a gas can take away a whole lot of the deionizing power of the resins. So you must have a carbon filter in before a DI resin filter. Okay, so the sediment filter will take out the big chunks of things, and the carbon filter will take out the chlorine and the fluorides. And by the way, this is a fairly typical under sink pure water system that you might find in a residential home. So what we're going to do is just start again from this point to say that we have water molecules that have come out from the sediment and the carbon, and they might look like this. And they've got negative molecules. Yeah? Some of them have got negative molecules. Some of them have got positive molecules. And now I'll show you what a DI tank looks like. So the DI tank is the big black tank in your system, yeah? And it looks like that. And it's actually got an opening for the top. And when it comes into the top, it is actually coming into the whole neck of the tank. So the water is distributing itself evenly through the tank and from the top. What's actually happening when inside the tank, there's a riser here. And this riser is the way that the water comes out. So if I just show you this, you'll see this, that the water comes in, evenly distributes itself, and you'll see soon that the beads, it's working its way through the resin beads, and then it comes to the bottom, and then it comes up and comes out. And that's the way the water flows. Now, what the tank is filled with is what we call mixed bed resin. And we call it mixed bed resin because it's 50% charged negative. Yeah, and you can imagine these are little tiny beads that are just packed together. We'll show you them later. Yeah, and so let's say half the tank was negative and half the tank was positive. Now, in actual fact, they're all mixed together, but for the purposes of this drawing, it's much easier to visualize it like this. Yeah, so these are supercharged beads, you know, way more than one molecule. In fact, 50 liters of these resin beads can remove 1 million parts per million of TDS, total dissolved solids. Yeah. So that's the sort of a ratio, and you can actually do all the calculations on flow and all that. Now, let's imagine these water molecules, lots and lots of them, Most of them have got nothing on them, yeah, no minerals or molecules or anything, so they come in and they're going to flow their way through here and they're going to flow their way down here. Now if I draw one of those little water molecules and I make them solid, if this water molecule has a little negative charge on him, he's just going to keep on flowing. He's not going to be attracted to the negative charge bead. But another little water molecule, he might be here, and if he's got a positive charged molecule, then when that positive charged molecule comes near a negatively charged bead, he will definitely jump across because the ionic attraction is greater. So that little water molecule jumps off there, and then this little water molecule here, I hope you can see him, he's going to wander his way through, and he looks like this now. He's just a water molecule, pure water. Now similarly, if there was another little water molecule that came through like this fellow, and he's got that, if he was down here, and he's got a negative, like a calcium or a magnesium molecule, that molecule is going to see this positive charge, and which is so much greater than the charge from the two hydrogens, and he's going to jump off the water molecule onto the positively charged bead and use up a section or a port on that bead. And then that little water molecule is going to carry on, and they're going to start finding their way up here, and they all flow up here. And what you know is that everything that comes out of your DI tank is what we say TDS 000, as long as these beads are active. Yeah? So all the positively charged molecules, all the negatively charged molecules that are ionically attracted to your water molecules which you put in there are all going to be removed